Hi, Samia. I think you started, but your mic is on mute. So can you return back? Can you hear me?
Yeah, I'm sorry, I can hear
Yes.
you and
Yes.
off from the
No
beginning.
problem. Can you start over? Thank you very
Yeah.
much.
So, hello everyone. My name is Samia Ashraf. I'm a Google developer expert for Flutter and Dart, a woman tech makers ambassador, and also an organizer at multiple Google led communities in Dubai and Abu Dhabi. And today at FlutterMENA, I will be discussing about testing strategies for Flutter developers. So let us discuss today's agenda. We will begin by discussing why testing is important, followed by types of testing, types of automation testing, after which we will look at how testing is performed in CI CD automated pipelines, after which we will see what is test driven development, and finally, we will see a code example where we write some code and then test that code. So let me begin by quoting a very powerful quote which says, "Every time you find a bug, it's a chance to make the software better." Now, I think this perfectly illustrates what testing and how testing is important in building an app or a software. Because every time you find a bug in your software, you're going to go back, fix that bug, and remove that bug from the app. So when you do it every time you find a bug, your app is going to be your app is going to have lesser bugs, and this is how you can build quality applications. So now let us see what is the importance of testing and what happens if we don't have the testing phase. Now here I have the software development lifecycle, which starts with planning, analysis, design, implementation. Implementation is where we write all of our code for the software, followed by testing and integration, and then maintenance. Now, once we write all the code, our app is then tested to see if the app performs as per the requirements expectations. Now, if we do not have the testing phase, and after writing all the code, if we directly publish the app, what can happen is multiple things can go wrong. Your app, because it has not been tested, it will have a lot of bugs. Bugs like overflow bugs. I'm sure we've all seen widget overflow bugs that can at some point crash the application. So if you don't have this testing phase, your app will definitely have the users will reduce because it's not having the perfect UI UX. So it's a crucial aspect of development. It will ensure proper app performance because you have tested your app and you know that your app is um, it's having lesser bugs. And it also ensures app compatibility because you have tested your app in different devices of different sizes, and will also maintain the brand name because obviously after testing the application your app will have lesser bugs. So we have a widget overflow error. I'm sure you've all come across this error. It's a very common one, and it happens when your widget is overflowing in the screen. Now, if these kind of overflow errors are not encountered during the testing phase, then this can crash the application, and it's not a pleasant experience for the user. So always test the widgets, try to catch these kind of errors and fix them before we push them to production. The next one is the application not responding. Now, this happens when your UI thread is doing a lot of work, and as a result of which the app crashes and the user is forced to either close the app or wait for it to resolve or respond. Now, again, this is not a pleasant experience because most of the times the user is going to close the app And if this happens frequently, then it means that you have not tested the app, because of which the app is performing this way. Some other type of bugs are routing errors. Now, again, these are very common, uh, unexpected feature behavior, and many more type of bugs. And one of the main reasons why this can happen is because we have dependency injection. You have applied it for routing, and you have made some spelling mistake, or there is a mistake in typing the name of the widget, because of which you will see this red screen. Again, the app is going to crash when it encounters a red screen like this. So these are the three main types of most common types of errors that can happen, and always look out for these kind of errors and solve them before you push the app to production. Now let us discuss what are the types of testing. So, first we have manual testing. Now, if you have ever built a portfolio app, I'm sure you've come across manual testing, because here the testers are humans. There are no automation tools involved. And the way you test is first you write down the test cases, as in which feature needs to be tested, how it needs to be tested, and then you perform the testing on your own. So there is no automation tools involved, and there is no most of the time there is no code involved as well, because you are testing it with the device. The starting cost is low because the testers are humans and there is no code involved. But one con of this would be it is very time consuming. If you are having a lot of test cases to perform, this is going to consume a lot of time and labor intensive, because the testers here are humans, so they are going to take time as well. And this is not meant for large scale testing, because again, humans can make errors. So if you're going to test for a very large application, it wouldn't be an ideal option to opt for manual testing. In such cases, you have to go for automation testing. This is the second type of testing, and the most common one we've seen in Flutter. Here we have scripts used. You will be writing code to perform the testing, and this uses automation tools. Now it involves starting cost as well, because we will be using software to write the tests, and this is meant for large scale testing. No, so if you're having an app that involves a lot of test cases, then the ideal option is to go for automation testing. Now, fortunately, in Flutter, the framework itself supports testing. So you don't have to learn a new language to write the tests in Flutter. You can write the test using the Dart language itself and test different features of your Flutter app. So yeah, in Flutter, you can do automation testing for a simple app or even a complex app. Now let us see what are the types of automation testing. So we have unit testing. Unit testing is where a single unit in the app is tested. Now this unit can be a function, a method, or a class. So it's just a single unit that will be tested. You will be writing code to test a single unit, a function. Next, we have widget or component testing, which is the most common type, where we will be writing the code that tests for a widget. And third, we have integration testing. Now, integration testing is where the complete app or the large part of the app will be tested. So, let me go to the Visual Studio and we will see them in action. I hope you can see my Visual Studio editor here. So I have by default the counter application. I have not made any changes in the app except for this commented code. Everything is the same, the default app. Now for unit test, what I can do is I will take a single unit. So just to keep it simple, I have a very simple function that adds two integers and returns the sum, which is again an integer. Now I will write a test that performs addition because this function does addition. So I'm going to say add 3 comma 5 and expect an answer 8. Now everything is fine here because a plus b, 3 plus 5 is 8. So whatever is my expectation, I'm going to write it here. So since the 3 plus 5 is 8, this test will return a successful result. It will say successful addition. Now, let's say during the testing, I want to test that, I want to make sure that the add function does not return wrong results. So I will give an incorrect expectation here. So now when I run this, it's going to throw an error saying that when 3 plus 5 is added and passed on to the add function, the actual result that is returned from the add function is 8, and my expectation here is 9, which is incorrect. So this way we can perform tests on individual units. So now let us look at how we can do widget testing. Remember, I told you widget testing is where we test an entire widget. And in this case, I'm going to test the counter widget. Now, by default, we have an increment counter which increments the counter value by 1. So here the code, this is again the default code that I have. Now if I run this code, this is going to say that increment counter by 1 was successful. Now increment counter by 1 was successful because first we're going to load our widget, and we're going to find a text widget, find dot text that reads 0. So initially our widget will be the text widget will have the value 0. So initially it has the value 0. Then next what we are going to do is we are going to look for another text widget which is 1. So at this point it shouldn't find the text widget 1 because we have not clicked on the button that increments 1. So the text widget at this point should be 0. Next, what we will do is tester.tab. Now find the icons.add, which is my fab button here, and I'm going to click this. So once I click on the button, then we need to look for the text widget 1. So if it finds one widget, which is of type text and which reads 1, it means that our counter was successfully implemented or incremented. Now, let's say in my functionality, for some reason, I'm going to increment the counter by 2. So now what happens at this stage is my test is going to return an error because when it tried to increment the plus button, the value did not increment by 1. Instead, the value incremented by 2. So this is going to throw an error. And that is how you can write the widget tests. Now, going back to our slides. So that is the type of the 3 types of automation testing in Flutter. Next, we have CI/CD pipelines. Now, CI/CD pipelines is an automated process, meaning, let's say I have an app and I've written an app and pushed it to production. Next, I don't want to spend time in the deployment in performing the deployment of the application, and I want to make it an automated process so that every time I have a new update in my app, I simply write the code, and then the deployment is automated. It happens on its own. So now between the updating code and deployment, the testing is compulsory. Otherwise, again, it can lead to app breaking. So the testing, what happens here is the testing is again automated here. Now, every time the code is updated, it triggers a series of tests. So every time I create a new update or add the code for an update, the testing is automated here, and it ensures that the application runs as expected by performing regression testing. Regression testing is where uh, any update in the app is tested before pushing to deployment to ensure that the app does not break at any point. So the testing will be performed, and then only the app will be deployed. And this is exactly what CI/CD means. Every time you code, you build, test, and only then you will release and deploy. So this is how the CI/CD pipeline works. So now the benefits of having CI/CD pipeline is early bug detection. Now, because this is an automated process, you will be able to catch bugs in the development phase, and you will not after the production. So what happens is, after production, if you encounter the bugs, then again you have to come back and fix that bug. So with the CI/CD pipeline, because the testings are automated, it will tell you before you push the app to production that so and so bug has been detected. Code confidence, because you will be confident that whatever code has been pushed to production is bug free, because the automated tests have been performed on that code. Faster time to market, because every time there is a new update, you are not performing all the steps for deployment, and because the testing and the deployment is automated, the updates are quicker and more efficient. Next, we have test driven development. So, test driven development is a very important element in building a software. It is where tests are written before the actual code is implemented. Now, what do I mean by that? You are not going to implement the code first, you are going to write the test for the feature first. Then the test is obviously going to fail because you don't have the code for that feature. After the test fails, you're going to come back, write the code to make that test work. And finally, you're going to eliminate the redundancy by refactoring the code. Now, the benefits of this is you know exactly what code needs to be implemented, because once you write the test and it fails, it will tell you what is missing. So you will go back and write only that code. And this will also um, help in early detection of issues, because you will know exactly what needs to be implemented. And it reduces debugging time, because you're not writing the code, testing, and then fixing the code. You are first writing the test which tells you what needs to be implemented, and then only you implement that and refactor. So it reduces the debugging time. And the refactoring here is very much simplified, because you obviously you will be writing what is required, so you will not have to spend more time in refactoring. And this is a very interesting approach also. If you have not tried TDD approach, I recommend you try it, because this will um, solve a lot of things, and it will make you better in writing tests also. And also it will give you a clear understanding of what the feature is, what is expected from the feature, and what code needs to be written for that particular feature. So we have three phases: the red, green, and the refactor phase. Red phase, like I said, it writes a test that fails. Green phase, is where we write enough code to pass that test, and then refactor is where you just refactor the code. So these are the three phases of TDD. Now again, let's go back to the Visual Studio Code where we write a test that fails, and then we are going to write the code to make that test pass and then refactor. So let me quickly switch to Visual Studio Code. I hope you all can see my screen. Now here earlier, let me just fix the error that I had created. Now at this point, the test works for incrementing the counter by 1. Now, let's say we want to increment the counter by 2. Now, I will not go back to the code and write the code for implementing incrementing counter by 2. I'm going to first write the test for it. So let's say here, increment the counter by 2. So from 0, once the button is pressed, the add button is pressed, we will be expecting a widget that is with the text 2. So let's run this code, the test code. So we have a, an error message here which says 0 widgets with the text 2 were found, obviously because our counter only increments by 1, which means none were found but one was expected. So let me go back to my code and fix this. So we don't need this now. We are simply going to say every time increment counter function, which is clicked when icons.add is called, increment the counter by 2 instead of incrementing by 1. So now let us see if this works or not. This should work because our counter now increments by 2. So now our test passes here because we have fixed the code where counter increments by 2. So this is how we can write the test, and this is how you can go with the TDD approach. So similarly, if you wanted to write a similar test, you can also have another test widgets function and perform different kinds of testing and go back and clear any code that is no longer required. So yeah, that is how we can perform TDD. Coming back to our slides. So that's all from my side. You can find me on Twitter, LinkedIn, and Medium. Do post articles on Flutter topics. So if you're ever interested, you can read them, and I hopefully you will learn something from them. And reach out to me if you need any help with Flutter testing or any topics in Flutter. I will be available and I will try to answer most of them. And this is also my website where you can find all the Medium articles. Thank you. That's all from my side.
Thank you very much, Samia, for a valuable talk. Um, I think if we have any questions also in the chat, we can
Yeah, sure.
ask, and Samia, we have some time. You can answer the questions.
Yeah, perfect. Any
Okay,
questions?
so
Any questions on Flutter testing or any topics you can ask me, and I will try my best in answering them.
Okay, so there's some question related to the previous session.
Yeah.
Okay.
Yes, I see one question.
Yeah, there's one question.
As a beginner in testing, do I start with unit test? Um, Unit test or widget testing, I believe it depends on the complexity of your app. Yes, if you can write unit tests for your app, then yes, you can start with that because unit tests are comparatively simpler than widget testing. But most of the times, because we write widgets in Flutter, you will have to write widget testings to test a widget for its feature. So I would say widget testing is what you are looking for if you're testing Flutter apps.
Perfect. I think we have another question.
Yes.
What is the best resources to master RHE testing?
What is the best resources to master the testing? You There is enough resources in the Flutter official talks website, so definitely you can check that out. And I would say practice on your own. Once you know what is unit testing, widget testing, practice on your own. Write some simpler applications and write tests on your own. And there are also enough resources on YouTube, I would say, that illustrate Flutter testing with different types of examples. So, yeah, YouTube and official Flutter Talks website is where you can find.
Okay, perfect. I think maybe it's the same question where we can find
Yeah,
more examples about testings.
yeah, YouTube and official Flutter Docs website.
Okay.
The next one.
Another
Yeah.
question from Muhammad.
In TDD, does the developer write the test cases or a tester? Now, it's usually the tester, but if again, if you have a tester, then yes, they will be writing. But as a developer, to ensure that what we have written, we can also write the test. So it completely depends on how the team functions. um, you can also write, because the tests are in Dart, we can also write the test cases. So yeah, I hope
Yeah,
that answers
amazing.
the question.
Yeah, thank you. Thank you very much, Sammy. I think we will stop here. Thank you for the valuable session. And I think we will move on with the next speaker.
Yeah,
We have
thank you.
Kareem. Thank you, Samia. Yes. Okay, so we have Kareem, so software development team lead at Take Time. She will talk about Flutter with barcode scanning. Um, uh, of course, we are using any barcode scanning in Flutter application and building different ideas. I believe will take you through how you can implement this feature in Flutter, and we'll come back maybe within maybe 1 minute, and we'll will continue.